Okay, let's take a look at one more property of exponents, and this time it's the quotient. We're dividing things. Okay, when you divide the two, you need to look at the powers. Whichever power is higher, that is going to determine whether the answer is going to stay on the top or on the bottom. Let's take a look. Here we've got n to the power 5 divided by n to the power 2. Now, what is n to the power 5? Well, that would be just multiplying n by itself 5 times, right? And then we have n squared, which is multiplying n by itself 2 times. Now, notice what happens. We can actually cancel. We have this property of canceling, right? Because we have something that the top and the bottom share, and that is n. We can cancel it here, and we can cancel it here. And when we cancel what's left, if there's nothing left, always put 1. Do not ever put 0, because if you're multiplying something by 0, that is 0. If you have a 0 on the bottom, that will be undefined. You can't do that. Okay, on the top now we have n times n times n, and that's n to the power 3. And on the bottom we have 1, but dividing by 1 doesn't change anything, and the final answer will be n cubed. Okay, let's generalize that. The rule is going to look like this. If I have a to some power, let's say m, and then I'm dividing by a to another power, let's say k. And I'm assuming that m is greater than k. For example, here 5 is greater than 2. Then what you have is you're going to get a to the power m minus n. Sorry, not n, k. M minus k. Okay, that will work over here because 5 minus 2 is 3. And is it going to work for any of the other ones? Well, yes, it is also going to work for part B. Let's look at part B. 2 to the power 5 divided by 2 to the power 4. Now let's look at the powers. We've got 5 and 4. Which one is larger? The top one is larger. We can use this rule, okay, because m is more than k. And we will get 2 to the power 5 minus 4. We subtract, but that's just 1. And 2 to the power 1 is equal to 2. Multiply 2 one time. Well, that's just 2. Okay, that'll be 2. However, that's not going to be the same rule in part C and part D. Now, I need to first show you the rule, and then we're going to get to C and D. For example, I've got 5 to the power 4 divided by 5 to the power 2. That's going to be 5 to the power 4 minus 2, right? As we just said, that now would be 5 squared. But what if it's the opposite? What if it's 5 to the power 2 divided by 5 to the power 4? Let's write it out. We've got 5 times 5 on the top, and on the bottom, you're going to get 5 multiplied by itself 4 times. Now, let's cancel out what is common here and here, right? And remember, if there is nothing left, then you must insert a 1, okay? And we're going to get 1 divided by 5 times 5. That's going to be 5 with what power? 2. Okay, let's generalize that. Here is the general rule. We're going to get a to the power m divided by a to the power k. But this time, the bottom is larger. So k will be more than m. What happens is it's going to give you 1 on the top, and on the bottom, you're going to subtract k minus m. Okay, now that we got the general rule, let's look at part C. A to the power 8 divided by a to the power 20. Which power is larger, the top or the bottom? Well, here 20 is larger than 8. That means that the power is going to stay on the bottom because the bottom is heavier, okay? On the top, you're going to get a 1. On the bottom, you're going to get a to the power subtract the 2 powers. 20 minus 8, that's 12. Okay, let me enter that here. 1 over a to the power 12. Finally, let's do the last one. 3 squared divided by 3 to the 8th power. Again, the bottom has a larger power, right? Because 8 is more than 2. Then we're going to get 1 over 3 to the power. Now subtract the exponents. 8 minus 2. What do you get? You get 6, right? And so that will become 1 over 3 to the power 6. Now, maybe you can compute what that is. Let's see if it accepts it. Yeah, it accepted it, so we're good.